lecture series on computer organization and architecture. We'll start with module number 5, that is lecture number 41. Contents covered in the previous lectures are module number 4. So under module number 4 we have discussed memory systems. So in case of memory system we have discussed different types of memories like primary memory, secondary memory as well as read-only memories and various types of read-only memories. So even we have discussed, so the one which is the fastest memory, that is a cache memory, which is used to increase the speed of the execution or in order to provide the good performance. And even we have studied regarding virtual memory concept, so which is used for increasing the size of the memory. So these concepts was covered in the previous lecture. Contents covered in this lecture are basic fundamental concepts. So that is, in basic fundamental concepts we are going to study regarding the basic processing unit, that is processor. So how the processor is going to execute the program or set of instruction. So which are the registers involved, which is a particular bus that is involved for execution. So what is the internal bus organization. So all those things we are going to understand in this lecture. Learning outcome: after this lecture the students will have a better understanding of basic fundamental concepts. So this is the Bloom's taxonomy pyramid, wherein we are going to understand the very basic concepts of processing unit. So hence it is going to fall under the taxonomy level number 1. So now in basic processing unit, so we are going to concentrate on the processor. So processor is used to execute the program or set of instructions or machine instruction, and it is also used to coordinate the activities of other units of the computer system. So this basic processing unit, we call it as simply a processor, or we call it as an instruction set processor, or it is also called as an central processing unit. A typically computing task consists of a series of steps specified by the machine instruction, so that constitute a program. So normally program means it is a set of instructions or sequence of machine instruction that is going to accomplish a particular task. So in order to perform a particular task we are going to execute the program, so wherein that program will be consisting of a sequence of machine instruction. So an instruction is executed by carrying out a sequence of more rudimentary operations. So now let us discuss the fundamental concepts. So we know the processor is used to execute the program. So processor fetches one instruction at a time, and it is going to perform the specified operation. So normally the program will be stored in the memory. So instructions are fetched one by one from the memory location, and every time only one instruction will be fetched. So once the instruction is fetched, and it is going to perform the operation that is specified in the instruction. So instructions are fetched from the successive memory location. So obviously instructions will be stored one after the other, hence the successive memory locations will be fetched for will be accessed for subsequent instructions. So fetching of successive memory location will be done until a particular branch or jump instruction is going to encounter in the program. So in order to keep track of all the which particular memory location needs to be accessed, so we are going to make use of an program counter. So program counter is going to keep track of the address of all the memory locations which is going to contain the set of instructions. So processor is going to keep track of the address of the memory location containing the next instruction that needs to be fetched for execution. So this is done with the help of the program counter. After fetching an instruction, the contents of the program counter are updated to point to the next instruction in the sequence. So once the first instruction is fetched, obviously the program counter needs to point for the address of the next instruction which is in the sequence. So here the next instruction, the purpose of the program counter is to point to the address of the next instruction. A branch instruction may be loaded a different value into the PC. So normally if it is instruction if we have a successive memory locations, if we have an instructions in the successive memory location, obviously program counter contents will be incremented. So suppose if we have a branch instruction, then program counter contents itself has to be loaded with a new value. So that is the target address has to be loaded into the program counter. So here normally the steps involved in the execution of an instructions. So which are the necessary steps? So that is going to occur when a particular instruction in a program needs to be executed. So before executing, it is very much essential to get that instruction from the memory location. So we can get the content of that memory location with the help of the program counter. Why? Because program counter will be pointing to that particular memory location. The content of that location will be loaded into the instruction register. So IR stands for instruction register. Program counter will be holding the address of the memory location, so wherein its content will be copied to an instruction register. So now if we assume that memory is a byte addressable one, so byte addressable meaning is, so every memory location can store 8 bits of information, and address provided we call it as an byte addressable. So if at all the processor is of a 32-bit processor, so then it needs to access 32 bits of information. So therefore it is essential that one word is equal to 32-bit. So 32-bit means it will be accommodating a 4 memory location if the memory is of a byte addressable one. So therefore it is essential to increment the content of the program counter by 4. So therefore PC is equal to PC plus 4. So first load the memory. First step says that copy the memory location content to an instruction register. Afterwards increment the content of the program counter depending upon the size of the processor. So that is depending upon the size of the processor. So afterwards further we can carry out the specified operation in the instruction will be available in the instruction register, so you can carry out the specified operation. So that phase we call it as an execution phase. So step 1 and 2 we call it as an fetch phase, whereas third step we call it as an execution phase. So now this is a single processor, a single bus organization of the processor. So this is the internal internally how the things are available inside the processor. We have a program counter, we have a memory address register, memory data register, we have arithmetic logic unit, and we have a set of general purpose register like R0 to Rn-1. We have a decoder and control logic, and all these things are connected with the internal processor bus. So along with that we have an important transparent register called as Y, Z and temp. So here one more component we have multiplexer. So and we have an address and data lines as well as control signals. So we have a control signals for ALU, and all these things are connected with the internal processor bus. So here address lines and data lines are the external bus, whereas this register things, all the register things are connected, we call the bus as an internal bus. So here the figure shows an organization in which ALU and all the registers are interconnected via a common single bus. So this bus we call it as an internal to the processor, whereas address and data lines of the external memory bus are connected to the internal processor bus via the memory data register, memory address register. So these address lines and data lines are connected to the internal bus with the help of memory address register and memory data register. And one more thing you can just note down here, the address lines that is connected to the memory address register, it is unidirectional, whereas memory data register, the data line is of bidirectional one. So here register MDR as 2 inputs and 2 outputs. So that is one is for incoming and another one is outgoing. So similarly here also, so you can transfer the data from MDR to outside and outside to MDR, and similarly here also from MDR to internal processor bus and from internal processor bus to MDR. So hence it is having 2 inputs and 2 outputs. So here the data may be loaded into the memory data register either from the memory bus or from the internal processor bus. So whatever the data we want to copy, so it can be copied to the memory data register, so with the help of the from the memory bus or from the processor bus. So the data stored in the MDR may be placed on either bus. So input to MAR is connected to the internal bus and its output is connected to the external bus. You can just check here, memory address register. So we have an input from the internal processor bus and we have an output from memory address register. So here therefore we have an input of an MAR is connected to the internal bus and output is connected to the external bus. So with the control lines of the memory bus are connected to the instruction decoder and control logic block. So we have a control signals, so those control signals of the memory bus, they are connected to the instruction decoder and control logic block. So this unit is responsible for issuing the signals that control the operation of all the units inside the processor and for interacting with the memory bus. So whatever the signals, the control signals, so those control signals will be that is control logic unit, that instruction decoder and control logic block is going to issue the control signals that are used to control the operation of all the units inside the processor and even in order to interact with the memory bus. So the number and use of the processor registers R0 through Rn-1 vary considerably from one processor to another processor. So here the total number of registers, so general purpose register, it will be count will be different from one processor to another processor. So register may be provided for general purpose use by the programmer. So some may be dedicated as a special purpose register. So say for example index register, stack pointer register. So some of the registers we call it as an special purpose register, like index register, stack pointer, program counter. So they are dedicated for certain functions. So they can't be used for a general purpose operations. And we have three important other three registers called as an Y, Z and temp. So they are used for temporary storage during execution of some instruction. So please note that they are made used by the processor for temporary storage sake. So it is not going to store the intermediate result of one instruction so that it can be used as an input for some other instruction. So these instructions are never used for storing the data generated by one instruction for later use by another instruction. So it is going to store the it is going to store the result of execution of some instruction, but that content will not be used by any other instructions. So we have a multiplexer MUX selects either the output of a register Y or a constant value 4 to be provided as input A of the ALU. So you can just check out here. So we have two input for the multiplexer. One is constant 4 and another one is Y. So these are the inputs for the multiplexer. You know what is multiplexer? It is having many inputs and one output. So among these many inputs, one of the input will be selected by the help of the select inputs. So select input is going to select either a constant 4 or Y, and it is given as an input for A. So if a constant 4 is selected, then it is selected because we are supposed to increment the content of the program counter, that is PC is equal to PC plus 4. So now suppose if the select input selects Y, so then it will be one of the operand of the specified operation. So say for example you may perform addition, subtraction, any logical operations or any arithmetic operation. So in order to perform those kind of operation, we require two operands. One is A operand and another one is B operand. So Y is going to provide the one of the operand. So another operand will be provided with the help of the internal bus. So here constant 4 is used to increment the content of the program counter. So we will refer the two possible values of mux control input, select as select 4 and select y, for selecting the constant 4 or register y respectively. So as instruction executes progresses, data are transferred from one register to another register, often passing through the ALU to perform some arithmetic or logical operations. So whenever an instruction is under the execution phase, so data will be transferred from one register to another register. So and then ultimately it will be made reach to the arithmetic logic unit. So in order to perform arithmetic or logical operation. So here the instruction decoder and control logic unit is responsible for implementing the actions specified by the instruction loaded in the IR register. So the decoder generates the control signals needed to select the registers involved and the direct the transfer of data. The registers, ALU and interconnecting bus are collectively referred to as a data path. So if we consider register, arithmetic logic unit and internal processor bus, so they all together we call it as an data path. And decoder generates the control signals needed to select the registers involved and direct the transfer of data. So now let us go for sequence of steps in the execution of an instruction. So now the thing is that how the sequence is going to take place. So first thing is that we need a data, and that data will be obtained from the memory location. So that data can be passed from one processor register to another register, or directly it is made available to an ALU. So if you want to implement any instruction, it requires obviously a data. So that data will be provided from one of the register or from one register to another register, or even the data may be made available to an arithmetic logic unit. So performs an arithmetic or logical operation and store the result in a processor register. So this is one method. And suppose if the data is not available in the processor register, obviously the data needs to be fetched from the memory location. So fetch the content of the given memory location and load them into the processor register. So you can get the data in this way also. And after execution, store the word of data from the processor register into a given memory location. So once the execution of the instruction is done, we are going to get the result. So that we call it as a data. That data can be stored which is available in one of the processor register to the specified memory location. So this is the sequence of steps in the execution of an instruction. So get the data from one processor register to another processor register, or even you can get the data from the memory location to one of the processor register, perform arithmetic and logical operation and store the result in a processor register. So further that data which is available in the processor register can be transferred to a specified memory location. So this is the execution of an instruction. So conclusion is, we have discussed of basic fundamental concepts. So under basic fundamental concepts we have discussed, so what is data path? So data path is collection of registers, internal bus and ALU unit. So even we have discussed what are the connectivity, so to the memory address register and memory data register, what is the role of decoder and control logics, and what is the purpose of the internal processor bus. So internal processor bus is going to carry the data from one register to another register, and we have an other register like Y, Z and temp, so that are used by the processor, and it is no doubt it is transparent to the programmer, but it is not made available to the programmer. So we have a multiplexer which is going to select either an operand or a 4 value. If at all we are using a 32-bit processor, 4 needs to be added to the program counter. So hence we have a mux component over there. So this is these things are discussed in this particular lecture. Thank you.